Hey, ninth graders, we are continuing with quadratic functions today. We're going to continue to talk about our vertex form. We are now going to combine together what we've been learning in our previous unit as well as what we're learning in this unit. And we're going to talk about the graph of a quadratic function in vertex form and how to turn something into vertex form when it is not already in vertex form. So kind of all coming together is the theme, I guess, of this unit, which is exciting. So we are going to first just practice completing the square. Remember that completing the square turns, turns quadratics into vertex form. I have two ones that we're going to practice together. We can practice, I'm going to practice B with you guys, and we're going to go through it all together and refresh ourselves on how to complete the square. And then I'm going to ask you to do A, which is slightly harder, or I don't know, it depends, easier, depending on how you feel about things, depending on whether you like fractions or taking out your greatest common factor. So this guy is going to have a fraction because what we do when we complete the square is we take your B term. Well, honestly, what I do first every single time with completing the square is I'm going to be adding something here, and I'm going to be subtracting out that same thing later. And so I just kind of provide space for the calculations to happen. And so then that way I only have to worry about one thing at a time. I think that is the biggest hurdle of most math students, is just focusing on one thing at a time. It's one step and then the next step and then the next step. And if you just focus on what you need to do in order to move to the next step, sometimes that can take away the fear that we have with a lot of problems. And just trust yourself that you know what the pattern is. You guys like math, that's why you're in this class. You know what the pattern is. It will come to you. You'll figure out the rhythm, the song of the problem, but just focus on one step at a time. So this is what I do to kind of help myself just focus on the first part. So I provide space to add something and subtract something away, knowing that this is kind of like the general idea of completing the square. And then what I do is I take my B term, which is 5, I divide it by 2, and then I square it. And I do write that out. When I'm dealing with fractions, I write that out, or else I make a mistake. And sometimes I'll only square the numerator, or I'll forget to divide by 2. Because then here I can say, oh, well, that's 25 over 4. And really, it doesn't really matter that this is 25 over 4 here, because we know how that's going to come out is this is going to be your perfect square trinomial, right? So that's just going to be x plus 5 over 2 squared minus, and then here is where we care about common denominator and all of those things. Common denominator would be 12 over 4 minus 25 over 4. That's negative 12 minus 25, so it's going to be negative 37. So that's going to be x plus 5 over 2 squared minus 37 over 4. So we've completed the square here. We've turned it into vertex form, and that means that we could then determine what our vertex is from this problem. Our vertex is, remember, why don't you tell me what the vertex is? So hopefully you tried your best. Hopefully you reference back to your notes, because that's what they're there for. And you can see here that, remember that this guy is supposed to be x minus h. And so if there's a plus here, that means that we must have plugged in a negative number in for h to turn this subtraction into an addition. So we know that actually what's going on here is that our x value for our vertex is a negative 5 over 2. And then since it's just plus k in the formula over here, then whatever symbol is here is what the sign was of the number that you plugged in for k. So if it's a minus here, then that means that we plugged in a negative number for k. So it's going to be negative 37 over 4. And that's our vertex. Kind of hard if I was like, put a point on 5 over 2 or negative 5 over 2. A lot of times we like to think about coordinates as decimals, at least I do. So that would be, it's okay if you write that as negative 2.5. I'm running over negative 9.25. Either one's okay. All right. I would like for you to complete the square on your own. And then from there, tell me what your vertex is. We'll do baby steps. Why don't you just complete the square on your own? Okay, so when we are dealing with a number in front of x, when we have a is not equal to 1, remember thinking back to your general form of ax squared. A is not equal to 1 here, a is equal to 3, so we need to factor that guy out, so we get 3, comma, and then x squared minus 2x. And then I know I'm going to add something here, and then I know I'm going to subtract that same thing later, except for one small caveat. The caveat is I technically didn't add in just this number. I added in 3 times that number, which means I need to subtract out 3 times that number here. Okay, so now I've provided space. I've set up the skeleton formula for my completing the square. Now I'm going to focus on the next step, which is that I need to figure out what is b divided by 2 squared. And that's going to be 1. So I get x minus 1 squared, plus 5 minus 3 becomes plus 2. So that is our completed square of this guy. Now I would like for you to tell me what the vertex is. The vertex will end up being positive 1, positive 2. Cool. So with that refresher, we are now going to apply what we know to 4 graphs. We're going to go through it quick. Hopefully it feels more like a refresher from last unit and not brand new, but if it's feeling brand new, that's okay. Lean into the new. Sketch a graph of each function, label the coordinates of at least 5 key points. What we're going to do first is we're going to turn it into vertex form. So I'm just going to quickly do it silently. You can follow along. I would like for you to also do it silently on your own. Which means that our vertex is -1, positive 4. So holding on to that, I'm going to draw, I can't find my ruler, so I'm doing this without one, please forgive me. I'm going to draw my x-axis way down here. Okay. Vertex at -1, 4. That's one of our key points. So here is another, we talked a little bit about this last note on our last notes, and here's like a pattern that we can follow. And so remember that the pattern is that you have these like key points that we start off with: 0, 0, 1, 1, -1, 1, 2, 4, -2, 4. That's the like pattern that I follow. And I know it continues that like 3, 9, -3, 9, 4, 16, -4, 16. But really those 5 first points, the vertex 1, 1, -1, 1, 2, 4, -2, 4, are our like 5 key points that tell us the behavior of what's going on with the vertex. And when a is equal to 1, which it is here, that means that our vertex, our parabola, and the vertex follow along that same pattern as they always do with your parent function, where the 1, 1 is the next point, which means if I wanted to go like up 1 over 1, that would be the next point in my parabola. And same one if I went, or like imagined almost, an xy vertex here and went -1, 1. And that's 0, 5, and -2, 5. And those points work. If we plug in -2, -2 plus 1, -1 squared is 1, plus 4 is 5, and that works. And so that pattern keeps continuing. We know that if we imagine this xy axis here, that 2, 4, 2, 1, 2, 4, and -2, 4 are also points on our graph. 5, 6, 7, 8, -1, 8. So it's kind of like shifting your focus and trying to imagine where would your parabola have been if it was just shifted, translated over here. And so it's just kind of like a really nice, quick way that you can do it without making a point, a series of points, a table of points. Okay, So this works. We can do it this way because we have a equal to 1 here. So notice a down here is not equal to 1. It's already in vertex form though, which is just swell. And we are going to practice this kind of like, I don't want to call it a shortcut because it's just following along with what you understand as the definition of parabolas and the definition of quadratics. And so it's just showing a true understanding of the behaviors of this graph to be able to kind of make that leap of like, oh, well, I just moved it this way, which means that really that pattern of up 1 over 1, or sorry, yeah, up 1 over 1, up 4 over 2 continues because I haven't stretched it at all.